Here we have a SAT math problem. Okay, let's go to the question. In the figure shown above, BC is the diameter of the circle. If the length of BC is equal to 132 and the length of AB is equal to square root of 363, what is the value of BC over BD? Okay, in the given figure, we have the length of the diameter BC, that is 132. So the length of the BC is 132, and also we have the length of the line segment AB over here, that is a chord of the circle. So its length is square root of 363. And we have to find the value of BC over BD. Okay, here we know the length of BC, that is 132. We can plug in this 132 for BC over here. But the length of BD, that is the length of this line segment, is not known. Only if I know the length of this line segment BD, I can plug in that value for BD over here, and I can get the value of this fraction BC over BD. Okay, here let me consider the right triangle BAC over here. How can I say that this BAC is a right triangle? So let's consider the point A on the circle. Okay, here we can consider the angle measure at the point A over here. Actually, this is the angle formed by the diameter BC of the circle. In a circle, at any point on the circle, so the angle formed by the diameter will be a right angle. So here at the point A on the circle, the angle formed over here by this diameter BC must be right angle. So here we have a right angle at the point A. So from this I conclude the triangle BAC is a right angle. And also let me consider an angle measure, interior angle measure at the vertex V. So let's say this is angle measure theta. Okay, now I consider this right triangle BAC over here. Let me write the stuff over here in right triangle BAC. Let me find the value of the trigonometric ratio cosine theta. When I consider this interior angle measure theta, the name of the side which is opposite to theta is called opposite side, and the length, the side BC is hypotenuse because it's opposite to the right angle. In any right triangle, the side which is opposite right angle is called hypotenuse, and the name of the third side AD is called adjacent. This AD is adjacent. Okay, then according to Secretto, the formula to get the value of the trigonometric ratio cosine theta is adjacent side divided by hypotenuse, and cosine theta is equal to, here this AB represents adjacent, so we can write AB for adjacent, and for hypotenuse we can write BC. So cosine theta is equal to, we know that the length of AB, that is adjacent side, is square root of 363, and the length of the hypotenuse BC is 132. That is given in the question itself. Okay, now in this right triangle BAC, I got the value of the trigonometric ratio cosine theta. Okay, now let's consider the angle measure we have over here. It has to be right angle because on the right side of the line segment AD over here is a right angle. On this side also we must have a right angle because we know that the measure of a straight angle is 108 degrees. If this part is 90 degrees and this one also must be 90 degrees. Now let's consider the right angle BAD over here. So considering this right angle, particularly the interior angle measure theta, so the name of the side AD will be opposite because this is the side opposite to the angle measure theta. And now this AB will become hypotenuse because it is opposite to the right angle in this right triangle BAD. Okay, let me write the stuff over here. This AB represents hypotenuse, and the name of the third side BD is adjacent side. Okay, now in this right triangle BAD, let me find the same trigonometric ratio cosine theta. Let me write the stuff over here. In the right triangle BAD, cosine theta equals to, again, the same formula, that is adjacent over hypotenuse. Let me write it. Cosine theta equals to, in this right triangle BAD, BD represents the adjacent side. So let me write BD for adjacent, and the hypotenuse is AB. Let me write it over here. Then we get cosine theta equals to, I do not know the length of BD. Let me write this one as it is. The length of AB is given in the question itself. That is square root of 363. Okay, let me plug in this value, square root of 363 for AB. Okay, here we got the value of cosine theta in the right triangle BAC, that is square root of 363 over 132. Here also we got the value of same cosine theta, that is for the same interior angle measure theta, that is BD over 363. Okay, here both these values are for the same trigonometric ratio cosine of the same interior angle measure theta. So they must be equal, that is square root of 363 divided by 132 equals to BD over square root of 363. Okay, now let me multiply both sides by square root of 363. Let me do it on the left side. Okay, when I do so, the square root of 363 over here and here will cancel out. When I multiply square root of 363 and square root of 363, I am getting 363 in numerator. In denominator, I am getting 132. On the right side, we have BD. Okay, now I got the value of BD. Okay, our aim is to get the value of BC over BD. Okay, now let me find the value of this fraction, that is BC over BD. It is equal to, for BC, we can plug in the given value, that is 132. And for BD, just now we got the value, that is 363 over 132. Let me write it, 363 over 132. Okay, now what we can do is we can write the numerator 132 as it is, and let me change this division as multiplication. When I do so, I have to get reciprocal for this fraction. The reciprocal of this fraction is 132 over 363. Okay, when I simplify this one, I mean when I evaluate this expression using calculator, I am getting 48. Therefore, the value of BC over BD is 48.